Continuing lesson 4.9 on using patterns to write and solve equations. On page 236, number 5, table shows Brenda's age B when Talia's age T is 7, 9, and 10. Find the pattern, then write a rule and an equation that represents the pattern, and then find Brenda's age when Talia is 12. So a lot of things they're asking us to do, so we got to make sure that we are doing all these things. Find a pattern, write a rule, write an equation. Okay, it says and, so pattern, rule, equation, and then we've got to find Brenda's age when Talia is 12. So 4 things they're asking us to do there. So if you look at the table here, you might notice if we look from Talia's age to Brenda's age, Brenda is always younger, and it's always by a set amount, which should be the case here. So Brenda's always looks like 5 years younger. So we could say, depending how we want to look at this, Talia is 5 years older than Brenda, or you could say Brenda is 5 years younger than Talia. Okay, that would be a pattern. A rule would be that we could subtract 5 from Talia's age to get Brenda's age. That would be an example of a rule there. And then an equation. We could have B equals T minus 5. That should be your equation. B equals T minus 5. We're taking Brenda's age is equal to Talia's age minus 5. Okay, and again, when you come up with the equation, what you can do is just think about what you're doing every time. We're subtracting 5, we're subtracting 5, we're subtracting 5. So we're going to keep subtracting 5. So if Talia's age was T and we subtract 5, then that would be T minus 5. And again, we have to have an equation. So we have to have B equals T minus 5 as our equation. And then finally, we could work this out and figure out that Brenda would be 7 when Talia is 12. You didn't have to necessarily have your equation in order to figure this out, but if you did have an equation, you could substitute a 12 in place of T, and then 12 minus 5 would be 7. On 6 and 7, they want us to use this table. So they're asking us to use the equation y equals 2x minus 7 to complete the table. Okay, so it's not just a simple calculation this time, but they're telling us the equation that we're supposed to use. Okay, so don't just say, oh, it went from 4 to 1, they must be subtracting 3. Or it went from 4 to 1, they must be dividing by 4. It's not that. It's 2x minus 7. They are telling us that on number 6. Okay, so using that equation, we're first being asked to put an x in place of 7, or a 7 in place of x, I should say. Might work better that way. Okay, so we put a 7 in place of x, and we multiply. So 2 times 7 is 14, and then 14 minus 7 is 7. So 7 should go in our first spot here. And then the second spot, same idea. We're going to substitute an 8 in place of x. So 2 times 8 is 16, and 16 minus 7 is 9. So this would be 9 in the next spot. Okay, now there is technically a pattern here as the y values are going up by 2 every time. You might notice a pattern that way. But that's what we would generally want to do to find the numbers that need to go in our table. Then number 7, state the rule for the pattern in words. The rule, they told us the equation. Basically just say that equation out in words. So we could say y value is equal to 2 times the x value minus 7. Okay, again, we're not creating that on our own. We're just taking the equation they gave us and just writing the words that would match up with that. Workbook page 57, the first part there, we're asking us to write a rule and an equation that represents the pattern in each table. So we're going to look for a pattern here. Again, trying to find a pattern going from our x to our y. So going from 3 to 5, 6 to 8, and so on. So if you notice, going from the x to the y, the numbers are getting bigger. And it's actually then going to be either adding or multiplying. Multiplying 3 by something to get to 5 is not a real nice number, so we can hope for adding, and in this case that is what it is. It's adding 2 each time. So for the rule part, we could just say y is 2 more than x, or you could say y is x plus 2. You could kind of write out in words what your equation is going to be. Okay, and then your equation would be y equals x plus 2. Since they're adding, if you put y equals 2 plus x, that would also be okay. Since we're adding. Final option, you normally don't put it this way, but technically we could say x equals y minus 2. Okay. To get an x value, you could take the y value and subtract 2 would give you the x value. So that'd be another way to look at that. So you look at number 2, going from the x to the y is getting bigger again. This time there's quite a bit of a difference between these, so you might suspect that they are multiplying, and that's the case actually. So you could say going from 2 to 6, 2 times 3 is 6, 5 times 3 is 15, and so on. So we could say y is 3 times x. So our equation, we could have y equals 3x. And again, this first part is our rule, the second part is our equation. So we have to have 2 different answers when we answer these problems. Number 3, the numbers are getting smaller as we go from x to y, if we look at it from that perspective. So I'm suspecting it's either going to be subtracting or dividing. Well, 4 minus 3 would be 1. 12 minus 3 is not 3, so that didn't work. Must be dividing. 4 divided by 4 equals 1. 12 divided by 4 equals 3. Okay, dividing by 4 works for each of these, so we could say, one way of saying it, we could say y is x divided by 4. So our equation, we could have y equals x divided by 4. And you can just write that as a fraction if you want, or you can write it out sideways, x divided by 4. A different perspective would be if we go from the y to the x. Y to the x, we're actually getting bigger. In that case, we're actually multiplying by 4. So another way of looking at that, you could say that x is equal to 4 times y. So either one of those would be correct. Kind of down the road, a lot of times we're going to have equations y equals something, but technically either one of those would be okay at this point. And if we look at number 4, on 4, these numbers are getting smaller, so we're either subtracting or dividing. And so they are subtracting 5 on each one of these here. So we could say, one way of writing the rule, we could say y is 5 less than x. Or you could say y is x minus 5, write out the word minus, M-I-N-U-S. We don't see it spelled out a lot, so it might look kind of funny to you. But then our equation, we'd have y equals x minus 5. If you did it the other way, you could say x equals y plus 5. It would technically be another equation that would work there. Next section, they want us to use the equation to complete each table. So on number 6, we got y equals 4x minus 4. Once again, this is not just a simple process of just adding or subtracting. We've actually got multiplication and subtracting. So what we can do here, first of all, if you write the equation down and then we're substituting, basically this is 4 substitution problems in one problem. Okay, that's all it amounts to. So first of all, we'll substitute a 2 in place of x. And then we're just going to use the order of operations. So 4 times 2 is 8. 8 minus 4 is 4. Then we'll substitute a 4 in place of x. I know they don't give you a lot of room here in your workbook, so you may want to, if you run out of room, do this in a notebook or something, so you've got space. I really prefer doing these problems, writing the equation first and then substituting. I've seen people different times try to do it without writing the equation on some of this type of stuff, and then they've had issues of substituting in the wrong spot or different things. So just taking the extra step of rewriting the equation is probably a good idea. Okay. So when you work that out, when x is 4, you should get 12. We could go through the process for the others, but I think you get the idea. You could work those on your own just to double check that you know what you're doing. But the next numbers should be 20 and 28 if you work that out. Okay? And even on a table like this, even if you think you see a pattern of saying, oh, they're adding this many each time on the y's, you can't necessarily say that, because the x's, the pattern might change. In other words, this case, yes, they're adding 2 each time to the x's, so they should be then adding the same amount to the y each time with the equation that we have, but that's not always going to be the case. And not right now, we don't have to worry about it. You guys will get into stuff later on in your mathematical careers where it's not always just going to be where you can just have a pattern of adding the numbers, but substituting always works. If we can substitute numbers and work it out, do the order of operations, that works every time. Okay? If we look at number 8, so 8 is basically the same idea. So we're just going to do some substituting here. So I'm going to write the equation first, and then I'm going to substitute. First, we're going to substitute a 0 for x. So first, if we multiply 1/4 times 0 would be 0, and then 0 plus 5 is 5. So our first value would be 5. When you do these problems, I should be seeing this amount of work, because it's not just adding something or multiplying something. One operation. We've got multiple operations going here. And really, even if we only have one operation, we should still be writing down what we're doing. The next thing they want us to do is substitute 4 in place of x. In this case, we are going to have something to work out for this first part. So remember, 4 we can rewrite as 4 over 1. And then if we multiply this, 1/4 times 4 over 1, that would be 4/4. which is equivalent to 1. And then 1 plus 5 would be 6. So if x is 4, y is equal to 6. And again, the same process you guys could go through on the rest of this. If you work that out, the other y values should be 7 and 8. So once again, the x's, they were consistent. They kept adding the same amount to their x values each time. So then that gave us a pattern for our y values every time as well. Number 11, Grace has $100. She is buying charms for her bracelet that costs $5 each. Write an equation showing the relationship between the number of charms C she buys and the amount of money she has left M. Okay, so if we think about this, we're probably interested in seeing how much money she has left. So usually what we'll do is make our equation starting out M equals something, since we want to see how much money she has, and then we'll see if we can come up with an equation that way. So the amount of money she's starting with is $100, so we can start with that in our equation. And then she's spending money, so the amount of money she has left is going to be going down, so we're going to subtract. Our charms are $5 each, so we're going to lose $5 for each charm that we buy. So if we take 100 minus 5 times C, okay, 5 times however many charms we buy, if we subtract that, that's going to tell us how much money she has left. So that would be our equation here. So if we look at number 12, they want us to use the equation we wrote in exercise 11 to find the number of charms Grace can buy before she runs out of money. So our equation, once again, we had M equals 100 minus 5C. And they're wanting us to figure out when she would run out of money here. There's a couple different ways. They're technically wanting us to try to use our equation, but there's technically other ways we could figure this out as well. So one way to do this is you guys could think about, we have $100, we're spending $5 per charm. So 100 divided by 5, and if you work that out, would be 20, which means Grace could buy 20 charms before she runs out of money. Another way you could do this, if they wanted us to actually for sure use the equation, would be if we run out of money, means the amount of money we have is 0. And then this is kind of like an equation. It's a little bit different than some of them that we've worked out at this point. So let's not try to extend what we've learned about too much here yet. But you could then just think about what value could we put in place of C that would make that work. Okay, so basically then we would probably be doing what we just talked about. 100 divided by 5 is 20, and thinking about, you know, if C was equal to 20, 5 times 20 is 100, and then 100 minus 100 is 0. So that works. Number 17, they want us to create a table to show the length of the rectangle when its width is 1, 2, 3, 5, and 8 units. And just to illustrate, that doesn't make a whole lot of sense if we don't read what's above there. So above there, it says in 17 and 18, the equation L equals 3W represents the length is 3 times the width. So L equals 3W. And we're going to, basically, we're going to be finding the length when these are the widths that we know. So one way we could set this up, we could make our width be on the top, and the length be on the bottom. So the width is what we know, 2, 3, 5, and 8. And then we're trying to find the length. So the length is always 3 times the width. So for our first one, if we substitute that in, that would be 3 times 2, which is 6. If we put a 3 in, to work that out would be 9. I had it kind of marked off here so I didn't see it. There should be a 1 here at the beginning. Can't squeeze that in real great, but if you put a 1 in, that'd be 3 times 1, which would be 3. And then you guys get the idea. You could fill in on the rest of these. Should be 15 and 24. And this one, they did not go by a set pattern. They went 1, 2, 3. They skipped 1 and went to 5. They skipped 2 and went to 8. So that's why we're not seeing the same pattern for all of our L values like we've been seeing in some of the other tables where they consistently went by the same amounts each time. Number 18, how could you use the equation P equals 2L plus 2W to find the perimeter P of the rectangle when its width W is 15? So if we go back to our equation, L equals 3W, we substitute that in, would probably be the easiest way. And 3 times 15, if you work that out, would be 45. So now that we know what our length and width are, we can substitute both of those values into this equation. So length is 45, width is 15, and order of operations, we do multiplication before addition. So 2 times 45 would be 90, 2 times 15 would be 30, and then if you add those together would be 120. They don't tell us what the units are, inches or feet or whatever, but 120 something is our perimeter for this problem. Number 19, we have a table that shows the total cost for the number of raffle tickets purchased. They want us to write an equation to find the total cost of 10 raffle tickets. So this one, presumably it costs the same amount for each raffle ticket. Not always the case, but that's what our thought might be. So if you do 417.50 divided by 8, and that will come out as 83.50, 83.5, which is 83.50. And it actually, if you divide that out for any of these other ones, it'll come out the same. So what that means is our cost is equal to 83.50 times however many tickets that we bought. Sorry, this should have been divided by 5, not 8 over here. Thanks for observant students catching my mistake there. So that's 83.50 for each ticket. So then for 10 tickets, we would take 83.50 times 10 is $835. So the cost for 10 tickets would be $835. So this gives you an idea of how to use patterns to write and solve equations.